All right, this is the last part of section 2.3 on average rates of change and equations of secant lines. Basically, average rate of change, simplified in terms of algebra, is simply the slope. So whenever you see in a question that says find the average rate of change, immediately think slope, okay? In equations of secant lines, we're going to be using various algebraic processes to find those equations of secant lines. So let's suppose we have a function here, and let's suppose its graph looks something like that, okay? And let's say we have 2 points here. Let's say we have a point A right here, and that point is going to be a f of A, and let's say we have a point over here with an x value of b. That's going to be b f of b as an ordered pair, okay? And this graph is and this is f of x. All right, well, the average rate of change between these 2 points here is simply the slope of a secant line containing those 2 points. So if we draw a line here, the slope of this line here is going to be what we call the average rate of change between those 2 points. Okay? And we can use the slope formula to find the slope of that line. So remember, slope is y2 minus y1 over x2 minus x1. And then to find the equation of a secant line, we can use either slope-intercept form, which is y equals mx plus b, or we can use point-slope form, which is y minus y1 equals m times x minus x1, and solve for the remaining variables or whatever, and get our the equation of our secant line here. Personally, many of you might be more comfortable when we find that equation using slope-intercept form other than point-slope form. Okay, so let's jump into an example here. I'm going to do one from the book, page 91, number 67. We're given the function g of x equals x squared minus 2, and we'll find the average rate of change from negative 2 to positive 1. Negative 2 to positive 1, those are x values. Okay. First thing we need to do in order to find the average rate of change, or the slope between the points on the line with those as our x values, we need to actually evaluate the function g at negative 2 and at positive 1. So g of negative 2 is going to be negative 2 squared minus 2, which is 4 minus 2, which is positive 2. So our first point is going to be negative 2, positive 2. The second point is going to be g of positive 1, which is 1 squared minus 2, which is 1 minus 2, which equals negative 1. So our second point here is going to be 1, negative 1. And it's at this point where we will use the slope formula to find the slope between those 2 points right there. And it doesn't matter which point you want to be x1, y1, and which one you want to be let be x2, y2. I'll let this first point here be x1, y1, and the second point be x2, y2. So for the slope, m, that's y2 minus y1 over x2 minus x1. Our y2 is negative 1. Our y1 is 2, so we have negative 1 minus 2. Then in the denominator we have 1 minus a negative 2 In the numerator, 1 minus negative 2 is negative 3. And in the denominator, we have 1 minus a negative 2. That double negative turns to be a positive, so we really have 1 plus 2, which is positive 3. Negative 3 divided by 3 is going to be negative 1. And this value right here of negative 1 is the average rate of change between or from negative 2 to positive 1. Okay, and what we'll do is we will use those 2 points and our slope, or the average rate of change that we just found, to find the equation of the secant line containing these 2 points. Okay? So if we remember, this point right here was negative 2, positive 2, and this point right here was 1, negative 1, and also our slope m was negative 1. So I'm going to use slope-intercept form, y equals mx plus b, to find the equation of the secant line containing these 2 points here, negative 2, 2, and 1, negative 1. It doesn't matter which point you want to use for x and y respectively here. I'm just going to use this first point, negative 2, positive 2, and our slope to solve for b. So our y value is going to be positive 2, our m is negative 1, our x value here is negative 2, and we're solving for b, or the y-intercept. So if we simplify the right side, we get 2 equals negative 1 times negative 2 is positive 2, plus b. Okay. So we get 2 equals 2 plus b, and then subtracting 2 from both sides, we get a value of b to be 0. So we essentially do not have, our y-intercept is basically at the origin here. Okay, so when we rewrite our equation in slope-intercept form, y equals mx plus b, we have y equals m, which is negative 1, x plus 0. Well, negative 1 times x, that's just going to be the same as y equals negative x plus 0. We don't really need to write the plus 0 there, because if we add 0 to anything, we just have this, what we're left with. So the equation of that secant line is going to be y equals negative x, or some people might write it as f of x equals negative x. It doesn't matter which way you put it or write it. Either way is mathematically accurate. Okay? So your assignment for today and tomorrow, I'm giving it over 2 days. Hopefully that'll give you a lot of time to work on these problems here. They're from the book, pages 90 to 91. Numbers 61 through 70. All parts. Okay, and I know we did number 67 together, so really that comes down to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 problems instead of 10. So overall, I think you should be able to finish this within 2 days, or by Tuesday the 6th at the end of the day. That's all we have for this section. I'll just put the note here that says make sure they're done by Tuesday. Okay, and that'll sort of wrap up section 2.3 on the various properties of functions.